Jai Hind, dear students. Here we are with the second part of our video based on the numericals of electricity chapter. Now we will be completing with all the numericals from the electricity chapter given at the end of the chapter of NCERT book. So we have practiced till question number 9 in the previous video. If you haven't seen that, just check it out. And here we are starting with question number 10, discussing the backside numericals of the chapter electricity from your NCERT book. If you have doubt in any other numerical also from electricity chapter, then you can just post your question in the comment section. I'll try to solve it out. So here we are starting with question number 10. It says that how many 176 ohm resistors in parallel are required to carry 5 ampere current on a 220 volt supply. So total potential difference is given 220 volt. Total current that could pass through the circuit is 5 ampere, and you are asked if you have 176 ohm resistors, how many such resistors could be connected in this circuit in parallel. So let's see how we can do that. Total potential difference is given 220 volt, total current is given 5 ampere, and the resistance of each resistor is given as 176 ohm. Now you have to calculate what would be the total resistance of the circuit. Okay, so using the potential difference and the current, we'll find out how much total resistance will be there in this circuit. So by using Ohm's law, we know that V is equals to IR. You have to write down that statement. Okay, by using Ohm's law, V is equals to IR. So R is equals to V upon I, and that is equal to 220 upon 5, and that will give you 44. 44 ohm will be the total resistance of this circuit. So now we have to find out how many resistors of 176 ohm could be used so that the total resistance comes out to be 44 ohm. We can use the formula that R in parallel is equals to R upon N. Means total resistance in parallel combination is equals to individual resistance divided by number of resistors. So R in parallel is equals to R upon N. So the number of resistors is equals to R upon R in parallel. So what is the total resistance of the what is the individual resistance of the each resistor? 176, and divided by 44. So that will come in the table of 4, and then we can divide it by 11. So you'll get the answer as 4. So total 4 resistors could be used in this circuit, so that you will have a total resistance 44 that is permissible in this circuit. Okay, I'll just shift aside so you can just take a screenshot of the solution, as well as you will be having all the formula with you. So you can note down all the formula that is there in the chapter at one place and use them whenever you are doing the numerical. Now question number 11. How would you connect 3 resistors each of 6 ohm so that the combination resistance once gave you a total resistance of 9 ohm and then of 4 ohm? Okay, so how you can do that? Whenever you are having any such question, remember, if you are having 3 resistors of 6 ohm each, and if you just connect them in series, then if all of them are connected in series, then total resistance will be 3 into 6, that is 18. It's too high, not given this question. If you connect all of them in parallel, then what will be there? 6 divided by 3. So the resistance of the circuit will come out to be 2 ohm. That is also not asked in the question. So we are not going to connect them in series nor in parallel. We are going to put them in such a way that some of them are in series and some of them are in parallel. Let's see what are the 2 possibilities we can use. Now we can have 2 possibilities. One is we can put 2 resistors that are parallel to each other, and whatever is the resultant, we can put another one in series of it. Okay, the other combination could be 2 resistors could be placed in series, and the another resistor will be placed parallel to the resultant. This is A and B. This is the 2 points ends. Okay. Now let's find out if each of them are of 6 ohm, that what will be the total resistance of the circuit in each of these cases. So it's each 6 ohm. Okay. Now when both of them are in parallel, we use for the first part that 1 upon R in parallel is equals to 1 upon R1 plus 1 upon R2. I'm showing each and every step, so make it a habit whenever you are doing any numerical, write all the steps, write down the formula with each numerical. So 1 upon 6 plus 1 upon 6, and you get that as 6 is LCM, 2 upon 6 is 1 upon R in parallel, that is equals to 1 upon 3. So R in parallel is equals to 3 ohm. Now this 3 ohm resistor and the 6 ohm resistor are in series with each other. So the total resistance, now the circuit will become something like this. This is 3 ohm and this is 6 ohm. So the total resistance will be in series, and that will be R1 plus R2, that is equal to 9 ohm. So we were asked to calculate resistance so that the total is 9 ohm. So we have got it. So we are going to place 2 of them in parallel and 1 of them in series with that. Okay. Every time you have such a question, just draw a figure to represent your answer. Second part of the question, let's move on. This 6 and 6 are in parallel to series to each other. So in series, that will be added up, R1 plus R2. That will be 6 plus 6 is equals to 12 ohm. Now this 12 ohm and 6 ohm resistors are in parallel to each other. So 1 upon R1 plus 1 upon R2 will be there. So the equivalent resistance circuit could be shown here before solving it out. So that was 12 ohm and the another one is 6 ohm. They are now in parallel to each other. Represent your answers in such questions with a small diagram that will represent what you want to say in this question. So 1 upon 6 plus 1 upon 12, LCM is definitely 12. So the answer comes out to be 1 upon 4 for 1 upon R in parallel. So the total resistance in parallel comes out to be 4 ohm. So you have got the answer as 4 ohm. Okay. So this is the second part of the question. I hope it's clear. You can take a screenshot. Okay. Now moving on to the next question. Question number 12. I hope you are able to solve these questions even without my help. You are solving it out by yourself first and then only checking your answers. For every question, there could be more than one possible way. So if you are doing it by some other method also, that might also be correct. Okay. Question number 12. Several electric bulbs are designed to be used on a 220 volt electric supply, are rated 10 watt. So we have many bulbs that are each rated as 10 watt. The power of each of the bulb is 10 watt and they are all connected in an electric circuit that is totally supplied with a potential difference of 220 volt. That is the total potential difference supply that we get in India. How many lamps can be connected in parallel with each other across the two wires if the maximum allowable current is 5 ampere? So it's given in the question that the potential difference is 220 volt and the current that could pass through the circuit is 5 ampere. And we are having many electric bulbs that are all having the power of each of the bulb is given to be 10 watt. So how many such bulbs could be used in the circuit? So we'll find out how much could be the total power of the circuit. Okay, and then we'll see how many bulbs will make a total of that much power. Okay, so total power of the circuit, total power that could be consumed from the circuit is equals to P equals to VI. V is 220 into I is 5. So it comes out to be 1100 watt. the total power that could be drawn from the circuit is 1100 watt, and the power of each bulb is 10. So if you multiplied by the power of each bulb with the number of bulbs, that will give you the total power of the circuit. So to get N, we have total power 1100 divided by power of each bulb. So 110 bulbs. Number of bulbs that we connected in this circuit is 110. 110 bulbs could be connected in this circuit. Okay. I hope you have taken the screenshot. I moved aside so that you can take the screenshot of it. Now, heading on to question number 13. A hot plate of electric oven connected to 220 volt line has two resistor coils A and B, and the resistance of each of the wire is 24 ohm, which may be used separately, in series, or in parallel. What are the current drawn in each cases? So these 24 ohm resistors, these could be used either separately. We can just use one of them at a time, or we can place them in series or in parallel. We have to see what will be the total current flowing to the circuit in all the three cases. It's a very simple question only. Question number 13. Total potential supply is 220 volt. Resistance of each of that is 24 ohm. So first condition is when we are using them separately. When used separately, the total resistance of the circuit will be 24 ohm only. Potential difference is given and you have to calculate the current. So by using Ohm's law, we get V is equals to IR. So I is equals to V upon R. If we solve it out, it comes out to be 55 upon 6. That comes out to be 6 9s are 54, 1, 6 ampere. Or you can write it as 9.2 ampere. Okay, so that was the first condition when we are using just one of them in the circuit. Now second condition is when we are using both of them in series. So in case of series combination, the total resistance of the circuit will be 24 plus 24, that will be 48 ohm. You will be writing R in series equals to R1 plus R2, that is 24 plus 24, that is total of 48. So now using the Ohm's law, V is equals to IR. So I is equals to V upon R. So it's 220 divided by R, that is 48. Now here we can do it by two ways. Either we can just solve it out as we just divide it, or we can divide this number by 2, because here we are divided by 24 and here we have to divide it by 48. So even if you divide this answer by 2, then also you will be getting the correct answer only. So we'll divide it by 2. So 4.6, it comes out to be 4.6 ampere. This is the second part when we are connecting them in series. Now third part when we are connecting them in parallel, then what's there? 1 upon R in parallel is equals to 1 upon R1 plus 1 upon R2, that is equal to So the total resistance of the circuit in parallel become 12 ohm. Okay, we knew that at the beginning only, because when two resistors of 24 ohm each are there and connected in parallel, that is R upon N, that is 2. The value of N is 2, so it will come out to be 12 ohm. Okay. So now we have to calculate the current in this circuit. So I is equals to V, that is I is equals to, okay, every time we need to write the formula also. So it's 220 divided by 12, and if you solve it out, let's find out. It will be either you can just solve it out or you can just multiply this number by 2, because here we have divided by 24 and here we are dividing it just by 12. So if you just multiply this answer with 2, then also you will get the same answer, 18.32, that could be written as 18.3 ampere. So that is how we can find out the answer in series, in parallel, or when used individually. So you can see this question is very important to draw a conclusion that when we are using the resistors in parallel, the current is maximum and it's minimum when you are using them in series. It's midway between them when you are using just one of them. So if you have a lot of number of resistors that are connected in parallel, then the total current of the circuit will be maximum. You can just take a screenshot of this question as well. Okay, so we have the next question, number 14. Compare the power used in 2 ohm resistor in each of the following circuits. Okay, we have two circuits, and in each of those circuits we have to calculate how much power is used by the 2 ohm resistor. We'll do that. First, let's erase this off. So let's do question number 14. 6-volt battery in series with 1 ohm and 2 ohm resistor. The first part of that is that we have a 1 ohm and a 2 ohm resistor that is in series with a 6-volt battery. And you are asked to find out the power consumed by the 2 ohm resistor. How much power is consumed by the 2 ohm resistor, that is asked. Now, whenever you are asked to find out the power, you first get the that in mind that power is very important, and we have in mind that we can use the formula P equals to VI to calculate the total power of this circuit. Okay, to calculate this I, we can get it easily by finding out the total resistance of the circuit and then finding out the current passing through the circuit. So let's find out the total current in this circuit. If we have to find out current, first we need to find out the total resistance. So total resistance is 1 plus 2, that is R1 plus R2, and that makes a total of 3 ohm resistance. Potential difference is given 6 volt. So current is equals to, by using Ohm's law, V upon R. So it's 6 upon 3 and the current comes out to be 2 ampere. 2 ampere current will be flowing through the circuit. Now if we use the value of I as 2 ampere, can we use the value of V as 6 volt in this question? No. Why we can't use it? Because in series combination the potential difference doesn't remain the same. It's V1 and V2. If the resistance is different, then the potential difference is also different. Even if both of them were 2 ohm each, then also this 6 ohm would have equally divided between the two. Okay, so the potential difference is 6 volt for the entire circuit, not for this particular resistor. So we have to find out the way, either we can find out V2 for this particular thing. How we can find out? V is equals to IR. So I we have got, R we know that, so we can calculate V and use the formula P equals to VI. Okay, I'll be showing you with both the formula. Okay, so the first way by which you can do this question is P equals to VI, but this V needs to be calculated here. So this is V1 and this is V2. Show in your diagram. So V2 is equals to V is equals to IR. So I into R2, that is the second. That will give you 2 into 2, that will be making 4 volt. Okay, so we will take the value of potential difference as 4 volt. So P equals to 4 into I is current 2 ampere. So that answer comes out to be 8 watt. What second way we can do is, instead of using P equals to VI, we will replace this I. So we know that V is equals to IR. So I can use the formula I into I, that is I square R. So now current we have calculated it 2 square multiplied by R, that is again 2, and that will again come out to be 8 watt only. So you can choose whatever method you are more comfortable with to do this part of the question. Okay. Now we'll be solving the second part of the question, in which it is said that a 4 volt battery is connected in parallel with 12 ohm and 2 ohm resistors. So we have a 12 ohm and a 2 ohm resistor. They are connected in parallel to a 4 volt battery. Okay, so we have to find out how much is the power consumed by this 2 ohm resistor. Okay, so we know that for formula P equals to VI. Now here we have to find out how much current is flowing through this particular resistor. Okay, so we can do it by that way, finding out the current passing through this particular resistor, or we can use one more formula. So I'll be telling you both the ways again. If you want to use P equals to VI only, first we'll find out how much current is passing through the 2 ohm resistor. So current, if we call it as I1 and I2, we need to find out I2. I2 is equals to V upon R2, that is V is 4 volt, R2 is 2, so it comes out to be 2 ampere. 2 ampere current is flowing to the 2 ohm resistor. So now we have to use P equals to VI. So V is given 4, I2 we have got 2 ampere, so it comes out to be 8 watt again. The answer is again the same. In this resistor also, the total power is 8 watt only. If we don't want to use calculate I2, we can do it by another formula also. In the formula only we can replace the things. P equals to VI. We don't want to calculate I, so we can replace it by I is equals to V upon R. So we get the formula V square upon R. V multiplied by V upon R will make V square upon R. V square is 4 into 4 upon R is 2. So the answer comes out to be 8 watt. Okay. So for both the parts, I have told you two options. Whichever formula you want to remember, whichever way you want to do it, both the ways it could be done, both the ways it's correct. Okay, and you will be getting the same answer both the ways. You can just take a screenshot if you want. Okay, so now question number 15. Try to do it out by yourself. Just pause the video and try to do it by yourself, or you need not even pause the video. You can just speed up. So by the time I'm erasing the board, you can start doing the next question and just complete it before I start it. Okay. Question number 15. Two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel to the electric main supply. What current is drawn from the line if the supply voltage is 220 volt? It's a very easy question. Question number 15. Total potential difference is given to be 220 volt. Two lamps are there. The power of the first lamp is 100 watt. The power of the second bulb is 60 watt. They are connected in parallel to each other and you are asked to calculate total current flowing through the circuit. Now you have two options. Either you can find out I1 and I2 separately. You all know that P equals to VI. Power is very important. So P is equals to VI. You can calculate I1 and I2 and just add them up, because in parallel combination that gets added up. Or you can do one very simple thing, that the total power is equals to power of the individual bulbs, and so we have 100 plus 60, so it makes a total of 160 watt. Okay, now you have the total potential difference as 220, total power as 60. You need to calculate the current. So you know that P equals to VI. So I is equals to P upon V. So P is 160 and V is 220. Just do the calculations and you will get the answer. It's coming 8 upon 11. If you divide that, you will get 0.727272 ampere, which could be written as 0.73 ampere. Okay, so it's very simple calculations and very simple question. You can just take a screenshot. Now question number 16. I hope you have got this answer correct. It was an easy one. Now question number 16 says that which uses more energy, a 250 watt TV set in 1 hour or a 1200 watt toaster in 10 minutes. Okay, so we have to find out the energy consumed by both of them. First we'll find it for TV. So power used by the television is 250 watt and the time for which it is used is 1 hour. And that for a toaster, power consumed by the toaster is 1200 watt and the time for which it is used is 10 minutes. Now the only thing in this question is you have to take the time of both of them in the same unit. Either you can use both of them in hour or both of them in seconds. Okay, that should be the same. Both the powers are given in watt only, so that are same only. We just need to take the time also in the same unit. So 10 minutes is equals to 10 upon 60 the hours. So it's 1 upon 6 hours for the second one. Okay, now you know that energy is equals to power multiplied by time. We have seen that energy is equals to power into time. So it's 250 multiplied by time is 1 hour only. So it's 250 watt hour. That is the energy used by the television set. Now let us compare it for the toaster. E is equals to power into time. Power is 1200 multiplied by time is 1 upon 6. So it comes out to be 200. So it's 200 watt hours. Okay. Since it's using 250 watt hour and that one is using 200 watt hour only, so the energy consumed by the television set is more than the toaster. Energy consumed by the television set is more than the energy consumed by the toaster. That's it, a very easy one. Agree to me? So you can take a screenshot and we'll do the last numerical from the chapter, and then we'll be completing our electricity chapter, all the numericals. And in text also some numericals are given. Don't skip them. Numericals from electricity chapter are very, very important. Every year numericals from electricity chapter are definitely asked. So prepare each and every numerical very well, from in-text, from example questions, as well as from the backside numericals. Don't leave any of the numericals. Okay, they are very important and definitely going to come in your board exams. In the blueprint of the board model papers also, they have given the numerical in both the parts. So definitely numerical will be there in the electricity chapter question for 4 marks. Next is question number 17. An electric heater of resistance 8 ohm, so resistance is given 8 ohm, draws a current of 15 ampere from the service mains for 2 hours. Time is given to be 2 hours. Calculate the rate at which heat is developed in the heater. You have to calculate the rate at which heat is generated in this heater. So you are not actually asked to just calculate the heat generated. You are asked to calculate the rate at which heat is generated. And rate of doing something means you have to find that value divided by time. So actually you are asked to calculate the heat generated per unit time. That is the meaning of rate at which heat is generated. So you know H is equals to I square R T divided by T. So just you have to use the formula I square R, and that is equal to I square is 15 times 15 times 8. 15 times 15 is 225. I hope you know the square 15. And if you multiply it with 8, it comes out to be 1800. The unit will be watt. Why? Energy per unit time. That is joules per second. So that will give you watt. Okay. So that is the last question from the numerical based question from the chapter. You can take a screenshot. One last question is there that I'm be telling you the answers for the question. Why is tungsten almost exclusively used for filament of electric lamps? Tungsten is almost exclusively used for electric lamps because tungsten has a unique property that it starts glowing on heating. So it starts emitting out light when heated up. Second thing is that it has a very high melting point, so it doesn't melt even at such a high temperature. Second, why are conductors of electric heating devices such as bread, toaster, and electric irons made of an alloy rather than a pure metal? They are made up of an alloy because alloys do not burn or oxidize easily even at very high temperature. So that's not going to burn even at such a high temperature. Otherwise, if it would have been a copper wire, that would burn at such a high temperature. Second thing is that they have a very high melting point also. The material is so selected and it has a high melting point, so it doesn't melt at that particular temperature. Why is the C part? Why is series arrangement not used in domestic electric circuits? In series combination, we can't use it in household circuits because in series combination, if we turn off one of the appliances, then all the appliances will be turned off. Second drawback of that is the total resistance of the circuit increases too much, and so the total current supply decreases. So every appliance will not be getting enough current supply also. Next is, how does the resistance vary with its area of cross section? So we all know that resistance is inversely proportional to area of cross section. So if area of cross section increases, then the resistance of the circuit decreases, and vice versa. Last part is, why are copper and aluminium wires usually employed for electrical transmission? Because this is because copper and aluminium wires are very good conductors of electricity. So for electricity transmission lines, we use these materials. Especially copper is an excellent conductor of electricity, and that is why in household circuits we usually employ copper for this purpose, being a very good conductor of electricity. Okay. So by that we have completed with the electricity chapter. If you have any doubts from any of the chapters in science, then also you can post your questions in the comment section. That's all for today. Good day everyone.